Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're in full swing of conference season here by the time this comes out. Yeah. Looking forward to going all over the world again with you, my friend.
Yeah, traveling around. That's part of the fun.
Yep.
A funny conference season this year because we actually spent most of October at home.
Yep.
Where normally you're always on the road in October. This year it's more November, December.
Yep. Should be good. Hey, let's just get right to it with Better Know Framework.
Awesome. All right, dude, what do you got?
Well, I think I've talked about this tool before, and we must have talked about it a million times. It's responsinator.com.
What's a responsinator?
Responsinator is a website you plug in a URL, and then you can see what it looks like on all manner of devices.
Oh, my goodness. Okay, that's cool.
Yep. I used it recently, and I was just like, if I haven't talked about this one yet, I should.
It's important, right? Just ways to look at what does your website look like on different form factors.
Plus, it's a cool name.
You just like saying it.
Yeah. Responsinator.
It's a responsinator.
I'm the responsinator.
You don't have enough responsive web design.
All right. That's what I got. What do you got?
Awesome. Hey, I grabbed a comment on our show 1471, we did back in August of 2017, or rather published then, because it's actually from NDC Oslo.
Right.
And that was the serverless panel we did with Rob Connery and Lynn Langett and Matthias Branderweiner. And a great conversation. We went all over the map with that one. And some awesome people jumped on board, too. Folks like Chris Love and Cod Pewter, who's a regular contributor to the comment session. But I want to read a comment, and admittedly it's a year old now, from our friend Thomas Betts, who's been a long time listener. And I know we've talked to him many times over the year, but this is a great comment. I always like a good panel show, especially when the guests are comfortable poking fun at each other, which was part of the dynamic of that show. It's a great opportunity to hear some different perspectives on a new concept or technology. I'll even put up with a high-level buzzword-centric discussion. However, I'm becoming more concerned when I hear people talking about serverless solutions as the great new thing. Anyone who's been in the industry for a while knows that no single technology is the right solution for every situation. For example, the panel even brought up the differences between C# and F#, as each has different uses for which they are better applied. There are many benefits that come from being able to deploy individual functions and scale them out as needed, as with all pay-as-you-go pricing models. But what are the trade-offs? The answer isn't always serverless. The answer is always, it depends.
It depends.
So what does it depend on? How easy or difficult is it to refactor 140 independent functions?
How much money have you got?
Without adding additional code to every function, what monitoring and tracing is available? And more importantly, what new design patterns need to be adopted and which old ones need to be discarded? Is it a good idea to have functions calling functions, or is it just a path to creating a distributed monolith? There's an interesting idea, distributed monolith. Sounds like a good rock band name, actually. The distributed monolith. These and many other questions would be great to hear discussed in depth on future shows. Serverless functions seem to be one more tool in the toolbox for building a system, but are not the only golden hammer that can or should be used.
Yeah.
I'm always appreciative of Thomas to call us out on, hey, you're a little too on the hype train here.
Yep, right.
Because in my mind, serverless has always been, I thought we went into this on that particular panel, this idea of, I have this existing, monolithic set of services, and I'm peeling them apart in some way. The ones that are struggling to scale would be my first candidates for sort of serverless approaches. But we're also seeing containerization being done that way too. Because when you get a complex set of interactions between a bunch of classes, you may not want to peel them all out as separate functions.
Sure.
You may rather keep them together in a container that can be scaled as a unit rather than scaled individually.
Right.
But, this is the nature of new tech and new approaches, and I'm sure our guest will jump on board with that. And Thomas, I don't know what .NET Rocks swag you have or don't have, but I'm going to offer you
everything
up. I hope he does. And if he doesn't, let's make sure he does.
I've seen him in a t-shirt.
Yeah,
I know
definitely see him in the t-shirt. But I will offer you up a copy of Music to Code By. And if you'd like a copy of Music to Code By, write a comment on the website at .NETRocks.com or on Facebook. We publish every show to Facebook twice a week even.
Yeah.
And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. They look good on all our devices. All right, and that brings us to our guest, and let me say this carefully, Maxime Rouiller. Did I say it right?
Yes, you say it right.
All right. Maxime is a Microsoft Cloud developer advocate. He's been in the tech industry since the 2000s and has been working with .NET as long as he can remember. A self-proclaimed master of all trades, he has set up VMs and SharePoint environments, built servers, and coded everything from desktop to server apps, but he truly found his passion around the web. Maxime was an independent consultant for 3 years before joining Microsoft. He also co-manages a local user group in Montreal. Welcome.
Thank you.
Yeah.
My first time on the show, actually, man. It's awesome.
What's up with that?
Imagine that.
Yeah, I've never been invited before. I don't know what was the hold up.
You never call, you never write.
Yeah, I think it's more of a we don't care for you, Quebecois. Maybe that's it.
So here we go.
Because we had Guy Barret on ages ago.
Yeah.
And Etienne Tremblay, and so maybe it's just we don't like you, Max. Maybe that's it. I don't know.
Ah, man,
mean. Canadians are supposed to be so polite. Richard, that was just mean.
We got to. If you can't tease Maxime, who can you tease, really?
Yeah, we're teasing. Like it's every time I talk with Richard, it's always been a pleasure. We often met at the MVP Summit together, so that was always fun.
Very cool.
Yeah, no. And I think this is one of those ones where we went around in a circle on this particular thing. I'm like, dude, that's a show, and he's like, yeah, okay, and then off it went. But it's one of those. I can't think of everything. People pitch me all the time, and you have that conversation. You're like, you're right. That is a very specific subject. I love that serverless is maturing, that we're starting to think more broadly about what this actually means. That's one of the reasons I read Thomas's comment, is it's like, we have to make sure all the ingredients are in place for this to be a real thing. I'd love your feedback, Max, on what you thought of Thomas's comment.
And I would agree. I mean, serverless has definitely evolved over the years. The first jokes that we had at the beginning was, well, serverless. Haha, I found the servers. Well, yeah. I mean, serverless is not about no servers. I would quote Jeff Holland from the Functions team as in, it's not about being without servers. It's caring about servers less.
Yes. Right. Servers less.
See the joke here?
Yeah, I get that.
Yeah.
The other thing that hit me the other day was realizing the original offering from Azure back in 2009 was the web roll, app roll. Dude, that was serverless. Like, that's really what it was. You didn't have any responsibility for the operating system, for any infrastructure at all. You just put your code up there and it scaled. And we didn't want it.
Yeah.
Well, in the web app, you could think of as serverless too. I mean, you don't deal with servers, but
one of the modern definitions for serverless now is it's really on what we call now the consumption model. Azure Functions itself right now is more like an application development model. As in, you're going to be building single individual functions, and this is going to be the way you're going to be deploying it. But the consumption plan on Azure right now is the whole essence of serverless. And that model is basically, if I'm not using it, I'm not paying for it.
Right.
And that for me is the essence of serverless. So anything that is VM or that is not, and that model is not really serverless. It's just I'm reserving compute.
Yeah, dare we say just plumbing? I don't want to pay for plumbing. Just run my code.
Exactly.
So durable is an interesting adjective to go in front of functions because, normally when something comes out that's new and it's durable, it implies that what was before was not durable, like the all-new durable Tesla Model S.
Oh, God.
Now with durability.
All right. So the whole point of durable functions is to answer something that is hard to do when you're basically responding to events. Serverless is great at responding to different events, like, something happened here, a message was sent in a queue and I need to unpile it, or anything along those lines where you need to respond quickly to events, and they may come like one or two or a million all at the same time. So you need to be able to scale, and serverless is excellent at doing that. But what if you want to chain those methods together. There's patterns that are really, really hard to do. Well, that you will need to actually do the whole architecture work yourself. But what if you could write that architecture just as C# code and have Azure handle it for you?
Okay.
That is where durable functions actually becomes insanely good. So there's a few patterns that are defined right now that we're constantly talking about, which is the first one is chaining. So that means I want to call functions 1, then I want to call functions 2, and I want those functions to be called in order.
Right.
So that is totally reasonable. But there's also the pattern called fan out and fan in. And that pattern literally means that I'm going to be taking a whole bunch of items that I want to have something to do with, and I'm going to be sending that to multiple functions. And then at that point, I don't really care in which order they're executed. I just want them to be executed all at the same time.
Yeah.
And once all of those have finished executing, I want to aggregate the result and send it out to, I don't know, a database or a storage or anywhere else to be saved.
It seems very map reduce-ish.
Yes, it might look a lot MapReduce-ish, but there's a lot of patterns like this that of applications that do those kind of things. So as soon as you're doing, like, I'm going to retrieve a list, I'm going to do a for each around it, and I'm going to save the result on anything.
Right.
If you're doing this with basic functions, Azure Functions 2.0, you're going to be either you're going to hope that you're not exceeding the execution time on our side and that all your functions is using 100% of the CPUs and the RAM that they can.
Yeah.
Otherwise, you're just paying for wait. I'm waiting for something to finish, which is not exactly fun.
No, it's a waste of money.
It's a total waste of money. So at that point, what do you do? And so one of the fun things I did with that is I wanted to have a way to resolve URLs because URLs change, and at some point, for example, a URL might be redirected or a domain might be dead. So I managed to resolve 175,000 of those URLs on a massive scale just for fun, in about, I think it's like 5 or 7 minutes. And that was durable in the cloud without me doing anything.
Wow.
It was pretty easy to understand. I could have probably done it better on my machine alone, but that pattern itself can be more complex.
Okay. But I appreciate we're just running through, these are the different options where this would make sense, right? Different patterns of where you'd want to use this.
Yeah. So one of the other pattern that is interesting is once you start this workflow, is how do you monitor that workflow? How do you make sure that it works? And we have code that allows you to retrieve, we give you an endpoint where you can actually basically monitor how's that function running right now. Is it failed? Is it still running? Or can I just cancel it?
Yeah.
Right.
And what if a function requires, for example, a human intervention? Yeah. So what if I need to like approve a workflow? So one of the examples that we could muster is what if I am ordering something? So I will have to need to check the inventory to make sure everything is doing fine. Then I will need to get the pricing, and then I will need to start processing the order. But maybe someone needs to approve the order. So how do you write this workflow in serverless without writing too much architecture code? So if you're thinking about the simple chaining, you're thinking about queuing up messages because you don't want to be calling functions directly. So calling functions directly, whether it's Azure or AWS or anything, it's actually a bad pattern to use because you're depending on a function directly. What you want to do is do it through a messaging event so that you can basically unpile those messages and scale out. And durable functions does all of that work for you, so you don't actually have to write this infrastructure code all the time.
Cool. So, because obviously there's a way to solve this. I'm immediately thinking about queues. Heck, you could write stuff into a database, but you're breaking out of the model here. So what's happening now is that Azure Functions are adding these models into Azure so that we don't have to jump out.
Exactly. So you don't really need to think about okay, now I need to create a queue because I want to have I will need to process those 100,000 elements. So I will need to queue them up. So I will need to create a queue. And now I need to have a way to unqueue this. What happens when there's an exception?
Sure.
So you will write this kind of code for weeks, and you would spend weeks writing this code to make sure that it is durable. And we do that for you.
Right.
So that's the power of durable functions, in my opinion, is this whole process becomes so much easier because you don't have configuration. Everything is in code in front of you. And for me, it's magic.
Well, that state problem was one of the reasons why, when we talked to those guys on that panel, that certain things don't allow themselves to be written without state. And it's always seemed like, okay, well, that's obviously not a good fit for functions, for serverless.
So I would totally agree, unless we're not talking about durable functions. Then I would have to disagree.
Yeah. This was way before durable functions.
So let's do a little durable functions deep dive. Bring your tank of oxygen with you and be careful so that it's not pure oxygen, because then it would be, just dangerous. So basically, at the heart of durable functions, when you start diving in, what you will see is this whole checkpoint and replay model. So each functions are either of two types. They're still going to be at the core an Azure function that is serverless, infinitely scalable. That's not a problem. There's two basic functions. There's going to be the orchestrator functions, which will basically orchestrate the flow. And there's going to be activity functions, which will be in charge of actually executing the work. So the orchestrator and the activity functions will be highly tracked. So that means that when something starts, you will have the input and the output of that function that will be stored. And every time something is moving forward, this whole state stays persisted. So that may end up with some funny behavior when you're debugging. For example, let's say that you're debugging an Azure functions that has, durable functions that has, a few hundred elements, and you're stopping it in the middle of execution. So you're going to launch, taking a break, enjoying the weekend, and then you come back on Monday, you start to debug your application again, and everything start resuming exactly where you left off.
Wow.
Yeah, that's confusing because you're like, I thought I stopped it, but no. Everything has been checkpointed, and it knows that it still has, 50 functions to execute with those parameters and those outputs to give. And the durable functions will resume the orchestrator and resume that whole work and continue where it left off.
So how does that work with your orchestrator? The sample I'm looking at on the docs site just shows a simple try catch in the orchestrator, calling 4 activities and passing the result of one to the next one to the next one. But if you catch an exception, how do you resume it? Do you just call the orchestrator again?
So here's a few things that are going to be a little bit fun. So when you're calling activity, when you're chaining it, I'm assuming you're looking at a chaining example where you have a weight on each and every one of them.
Right.
So when you await those, the way that .NET works is when you await a task, if there was an exception that was thrown, it will rethrow. So that's basically what's going to happen here. So it will stop at the first exception, and you will have to do this error handling yourself. If you're looking at another pattern that is fan out, fan in, then in this case, we're not awaiting those functions.
Right. We're
just calling it up and storing it. Now, how do you handle exception in those cases?
Poly?
That's the interesting part. Poly. You're actually half right, because we do support retries on those activity functions when you're dealing, for example, with flaky services that are from third parties that you don't really trust, but you want to make sure that everything works. So yeah, we can retry. But the thing is, when you're going to call task.whenAll, this is where if there's a single exception in those tasks, well, it will serialize that exception and throw at that moment.
Yeah.
Right.
Because that's how it works.
Yep.
And guys, I don't mean to interrupt right now, but we have to stop for a moment for this very important message.
Hi, this is Richard. The Dev Intersection Fall Show this year will be December 3rd to 6th in Las Vegas at the MGM Grand Hotel. The lineup is awesome. Scott Guthrie, Scott Hanselman, Scott Hunter, yes, all the Scotts. But also a ton of great industry speakers for some insight on what's coming up in the world of .NET. You know, Core 3 is bringing client technology like WinForms and WPF into play. Could it be time to migrate your existing desktop apps to this new technology? Come learn more at Dev Intersection, December 3rd to 6th in Las Vegas at the MGM Grand. Go to devintersection.com to register and use the code .NETROCKS to get a discount.
And we're back. It's Richard Campbell, Carl Franklin, talking on .NET Rocks to our friend Maxime Rouiller. Nasty.
Hey,
it's not bad.
Not bad.
Yeah,
Not bad.
you know,
Not as good as mine.
Yeah. You know, it's a Canadian
We're
thing.
going to have to give up.
You know,
We're going to have to give up points. See who does it better.
yeah, we could go back and forth on that one, but it's not actually the subject. This is very cool stuff, right? Talking durable functions and just thinking through when you have a dependency and when you don't have a dependency. And actually, I want to poke back a little bit because we were talking about the billing side of this as well. When you're talking about function chaining, so you have a dependency on you. Function 2 is not going to run until function 1 completes, right? So effectively,
Yes.
am I only being billed while each function's running? So by using this, it'll cost me less?
Each function is going to be run exactly once. So since we're talking about a checkpoint and a replay system, each activity functions will never be called more than once.
Right.
So each activity functions are going to be billed for their time of executions in the scenario. What is going to be special, however, is the orchestrator function, because the orchestrator function will need to orchestrate the whole thing.
Right. So it's running the duration. It's the nature of an orchestrator.
Orchestration functions are what I call special.
Right.
Not in a bad way. There's
so many versions of special.
Yeah, and a very specific version of special, as in they will be run again to monitor where we are in the process. So there's two things you need to know about orchestration functions is first, they're going to be called over and over and over again. So you need to make sure that they are deterministic, as in don't do datetime.now. This is not the time for that.
Right.
You will need to push that into an activity functions. And so when you take care of that, then that functions is just like any other function. So it will be billed once per execution. So it may be a little bit higher than most, but it allows you to not be that function that will be run for, I don't know, an hour because it's how long it took for your workflow to be done.
Right.
So instead, what it's going to do, it's going to start once, queue up a bunch of functions, and then resume execution when it notices there's a change.
And I admit, we're arguing over pennies here. I mean, my experience, functions cost very little. But when you get millions of them running, these efficiencies are going to start to matter.
Yes. And when you're using Azure Functions for an API like Troy Hunt has done, basically I think the cost of a coffee per month or something like that. It's like literally pennies.
For Have I Been Pwned?
Yeah, Have I Been Pwned? Which is an excellent website that should go on and try out and be scared because your email has probably already been pwned already.
Yeah, pretty much guaranteed. Do you use the internet? You've been pwned.
You've been pwned. The answer should be yes. Just go to the website. It just says yes.
It'd be a lot fewer functions if it just said yes when you went there.
Yeah. So basically, you run that website on pennies, and that's literally it. What I'm proposing here with durable functions is not to run something as complex as what you run, but more like how can you build your workflow and your company with orchestrator functions and split up the work? Because here's another thing that people maybe don't understand initially about durable functions and orchestrators is Orchestrator can orchestrate orchestrators. So it's just like this. It's just like this meme. Like, yo, dog, I heard you like orchestration functions, so I put an orchestration function in your orchestration functions.
It's orchestrators all the way down.
Exactly. So now imagine that you're having a team of people that are each team is working on their orchestrator, and the only thing you need to do is write a good master orchestrator function. And I think it kind of revolutionized the way we work in some ways. I'm not saying that it's like we reinvented the wheel and everything works, but I think it allows you to think about the way you develop software in a serverless environment in a totally different way.
Yeah, absolutely. No, it definitely broadens it. And it's one of those things where I'm sitting back going, wow, I could do this and then I could do that. Like, we're back to this whole, hey, it's your foot. Which way would you like to shoot it off? We have a lot of choices.
Yeah. We'll never stop you from shooting your foot off.
No, it's basically the measure of a valuable tool, right? It's got to be powerful enough that you could seriously harm yourself with it. Then it's probably valuable. As soon as someone presents me with a really safe tool, you immediately start feeling like these constraints hold me back from doing stuff I need to do.
So, do you want to hear how I shot myself in the foot with durable functions?
Yes,
yeah,
I do.
Definitely. Bring it, man.
I get a collection of tweets saying, like, literally, thank you for breaking our stuff. So that's cool. So here's the thing. So remember how we were talking about the checkpoint and replay and how it stores the input and the output, right?
Yeah.
So and you were asking what happened when there's an exception that is thrown. Well, the exception becomes the output. Cool. All right. Now let's chain up 175,000 functions. And let's have, I don't know, 5% fail. So we're about at 8,000. And the thing is that the orchestrator function is going to, when it does come back, it will actually reiterate the result from all those call activity async every time because it needs to know what happened.
Right.
Except that you have 8,000 of them. So I was literally killing off Azure storage. And
you're running out of space.
Like 20 minutes. It took 2 hours.
Oh,
it took literally 2 hours exploding in memory. Things were exploding left and right.
Hey, did a little bell go off on Scott Guthrie's desk? Hey, Azure has slowed to a crawl.
And it's Max's fault.
Jeff Allen.
What the?
Yeah, and that's not all, because the orchestrator, when it has a wait task done at all, if you don't do a try catch on that, it will throw. So that whole exception stack trace will become an aggregate exception of all the other exceptions.
Wow.
And that will also be stored as the result.
That's a big error message.
You
That's
needed
a
the Terminator.
So I was running at 143 instances. And yeah, I don't know if a page went off somewhere, but I hope not.
Hey, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yeah, it's time to wire up the Orchestrator, Responsenator, Terminator, and our Constructionator, which was called with our ILC Containerator.
Pretty sure you started with a Responsenator today, too.
All right. It's actually time to give away a $200 Amazon gift card, compliments of Progress Telerik, to one lucky member of the .NET Rocks fan club. But first, let me tell you about the most comprehensive developer toolkit for building modern apps on the market today, Telerik DevCraft. With more than 1,100 Telerik.NET and Kendo UI JavaScript components and controls, you can easily build modern, high-performant web, mobile, and desktop apps, as well as chatbots. The toolset also includes reporting solutions, automated testing, and productivity tools, and comes with a range of support options. New this year is a free online training program for all license holders. With this, alongside thousands of demos with source code, comprehensive docs, and a full assortment of Visual Studio templates, you'll be up and running with the Progress Telerik and Kendo UI tools in no time. Download a free 30-day trial today at telerik.com/download.
All right, buddy. Who's our winner?
Today's winner is Sean Farmar.
Congratulations, Sean. Golf clap for you.
Golf clap for Sean. Sorry if I butchered your last name, Sean. And just for being a member of the fan club, Sean just won a $200 Amazon gift card from Progress Telerik. And if you want to join the fan club and take a shot at winning some great stuff, all you got to do is go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and you're in the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors, and every December we give away a $5,000 technology shopping spree to one lucky member of the .NET Rocks fan club. But you're not going to win unless you sign up, so do it now. We also like to ask our guests, Maxime, if
Yes.
you had $5,000 to spend on technology, what would you buy?
So I have this idea, and the thing is, I'm Canadian, and I looked at the price, and the Surface Studio would be the one.
Okay.
Except
The
that
new
you
one.
said 5,000, and the pimped out version is 6,000 Canadian, but 4,800 US.
There you go.
So I went. Exactly. So Surface Studio is just this gorgeous device that
it's so pretty.
I would have probably zero use for,
Yeah.
but it's just I need it.
Yeah. I just need that display. I want that display.
Yeah, I want just the display because the graphics isn't the best in it. I mean, it is okay, but it's not great.
Yeah.
And I ended up going with an all-in-one from Asus.
Yeah.
You guys gave away some stuff. Can I give you 2 links
Sure.
for your team members? I mean, let's call it like a giveaway or whatever. It's not that big.
Yeah,
Sure.
But just to keep up on the subject, if people want to go and on aka.ms/serverless mixtape, yes, I made you a mixtape. This is basically just a YouTube playlist of the most relevant stuff about Azure functions and durable functions. It's nothing more than 9 videos, so it's super easy. And if people want to try something along the samples that is not the hello world and want something that is more realistic, I have a aka.ms/durable function sample that is amazing because it works with GitHub.
Great.
Awesome.
Yeah, thanks.
My pleasure.
Yeah, that's good stuff. I'll include those in the show notes for sure. Let's dive back into this. Where do we go from here? I don't think we've even gotten through all of the different architectural models. I mean, you spent a lot of time just on chaining and fan out because obviously there's like one's got dependencies, one doesn't have dependencies. Just go as fast as you can.
So those are the most basic patterns that will lead you the furthest.
Mhm.
And then you can go on our docs, like docs.microsoft.com/Azure/Azure Functions, and you can learn a little bit more about this. But if you're heading out to the samples that I provided to you guys for the example on GitHub,
Right.
it's basically what I did with the different things that I broke. It's just a slimmed down version. So that will allow you to do the work and understand a little bit how things work, because I'm using a little bit of chaining here, a little bit of fan out here, and that gives you a real example of how things work.
Sure.
If you want to get further, I will provide you guys a few links from the show notes where you will be able to read about the different patterns and how they are implemented both in C# and in Node.
Right. Of course, we are relatively language agnostic here, right? Like it's Azure.
Yeah.
It doesn't care what language you're in.
Yeah. So basically, Azure Functions released on 2.0 like very recently. I think it's like at Ignite. Durable function has been GA since May, so it's been like way longer.
Okay.
So yes, it was a GA product on a preview product, but now everything is GA, so you can go run .NET on durable functions, both in Azure Function 1.0 and 2.0 with .NET Core. And if you want to run on Node, Node is still in preview, so there are still a few things that might not be working quite yet.
Okay.
But it is getting better, and the whole scenario of chaining and fan out, fan in actually is enabled on durable functions for JavaScript.
Yeah.
And we are talking about scenarios where some of this stuff might run for days, right? Is that a reasonable scenario here, or are we still talking minutes?
Oh no! It can be days, weeks. It's not a problem.
Mhm.
It is made also for a long running process. So let's take the scenario where I think it's this pattern called human interaction,
Right.
where you basically start an approval process and you want to wait
Right.
until somebody
Give someone a couple of days to decide. Yeah.
Yeah. So normally you would not want to wait for a single person to approve a scenario. So you would want to have kind of an expiry date on your wait time, because what happened after 5 days to that things were supposed to ship, well, maybe it's not relevant anymore.
Right.
But basically you can wait days, and you're only going to be billed when that process runs.
Right.
And we know not to run anything like that until we're ready. And that happens in two ways. So when you want to have a human interaction, what's going to happen is either we're going to wait and we know exactly when it's going to be expiring, so we know when to run that function again, or what's going to happen is somebody's going to submit an event for Dribble functions to listen to, which will be just internally a queue, that a message in a queue that will be logged and unpiled. So it's still just responding to the basic building blocks of serverless.
Right.
It's queuing messages and responding to this. And that's it.
Mm-hmm. What are some of the other patterns that you can do with durable functions?
So the patterns that are, for me, the most interesting is not when you're talking about a single pattern like when you see in the code right now. It's more like what happens when you start mixing them up together.
Hybrids. You can call yourself. You can do eternal orchestration. You can just do a single orchestration. What about fanning out and calling sub-orchestration as a fan out? Yeah.
That's completely another valid scenario.
Mm-hmm.
Mm-hmm.
And a few things that you can do, for example, let's take a simple example where you're responding to what we call a blob trigger. So a new file is uploaded in your storage account and you want to trigger an Azure Functions. So what you do, instead of just starting a classic function, you start a Dribble function, and you can have something like Face API from Azure that will be able to say, is there anyone in that picture that was just uploaded? And if there is, well, you can add it somewhere in a different queue, or you can process something else in that Dribble function. So you can start mixing them up. It doesn't have to be a single HTTP event. Everything can be started from any other kind of triggers.
And a logic app plays really well into this, doesn't it?
Oh, yeah. And so now the question always becomes, what's the difference between Dribble functions and logic apps? And we do have a docs on this, I agree. For me, it's all about how much control do you want to have over the code?
Right.
And how much do you want to play in code or in a design errors?
Yeah.
So logic apps have a ton of connectors that are already built for you. You don't have to do anything. It's already there. And you can even call Azure Functions out of the logic app, so that's not preventing anything out of this. So it's a different programming model, but it's basically the same functionality that you can have.
I wonder how much that conversation that we had on that panel would be different if Azure Functions were in there. I mean, it just turns serverless on its head, right? And now you have state, you have this organization, you have all the orchestration, and now it begs the question, what are some of those app scenarios? And we've been talking about a few of them, but what are some of those scenarios that we wouldn't have used functions for before that now we can?
I agree. It turns things on its head, and there's a ton of scenarios now that you can think about, because now you don't have to think about the whole orchestration of creating queues and events and ensuring that there's only one consumer of that message. What happens when there's an exception, and all of this, I call it infrastructure code.
Yeah, plumbing.
The plumbing, it becomes heavy, and it stops you from just coding something real quick and having success with that. And how much of those problems that are just lying around right now and that don't have this orchestration power could be solved in a matter of an hour and just released.
Yeah, just put it out there. I also wonder if this isn't the path for an existing app using functions that is ready to go to a next level of sophistication, and you're looking at a rewrite. And you're like, I don't need to rewrite this. I just have to use the orchestrator, and off we go. Like, these things just work for me. Like, I could see both scenarios. I mean, you guys aren't doing any voodoo here. I'm sure you're using queues and stuff under the hood. I just don't have to own them.
Yeah, exactly. So I talked a little bit earlier that it was magic, right? But it is not magic. I mean, we went a little bit deep dive and we understood that it's just queues in the back. It's just we're just storing elements in storage, just like the input and the output. We're using both queues and blobs, and we even add tables to that. There's no magic. It's just we're taking the plumbing that you would have to write anyway for those kinds of complex scenarios, and we're letting you just write this scenario by yourself in code without having to understand like what's going on behind it. You just write the code and we'll take care of hooking up everything for you.
Yeah, I totally appreciate that. Like I said, it's just plumbing code I never wanted to own in the first place. I would argue it will actually cost me less to use your durable architecture, because you're only billing me for the functions I run, than it would be for me to roll this myself, and I now have to pay for the queues and the handlers and the orchestrator myself.
So a lot of those things that, for me, in terms of cost, the things that I will see, it's not even the queues and stuff that is the problem is this code that is doing this whole infrastructure, the plumbing. You have to maintain it,
right?
I mean, functions in storage is basically cheap. It's like cents.
Yeah.
So you don't really have to care about that. What people care about is how long does that developer that I hired is working on plumbing, and we're just basically taking that question out of the scenario completely. And we're just like, dude, just write code. Just
write the work and declare the architecture you need.
Let the code addicts do what they like to do.
Exactly.
Ooh, somebody's
channeling my Billy Hollis right there.
Here it is, right there. He just showed up. I heard Billy.
You have some more of them orchestrators. Yes, we do.
Yeah.
The big strength here is that when you need to scale, this is what functions were built for. It's just scale, scale, scale.
Yeah, and it's still serverless because you don't pay for what you don't use.
Right. So what about instrumentation diagnostics? Like when I'm having an unexpected set of behaviors with functions, how do I figure out what's going on?
So that's always a fun part, because functions are going to be exploding left and right. And I'm not talking about just about Azure functions. I'm talking about any other serverless functions you're going to be using. Somewhere down the line, somebody's going to write code that will not handle an exception and it's going to explode. How do you know what happened?
Right.
And we automatically connect application inside to your application if you want us to.
Right.
And we do provide a view in Application Insight that is called Live Metric Stream, if I remember correctly, and basically allows you to see in a real time the flow of execution of everything that is going on. So you will see the amount of instances that we're provisioning for you. You will not know the specs of those machines, but you will know there's 100 machine, 50 machine, or 2 machines that are being provisioned for you, and you will see the events. So if you're writing to the console, you will see those events pop up. If you have exceptions, they will be shown there. And you will be able to understand everything that is going on at that point. And if you really want to get deeper, the whole workflow is available in your storage account. So you will be able to see that function with that input resulted with that output. And that point, it could be an exception. So it will be able for you to replay those kind of things. Nice.
So it's all visible there. But App Insight sounds like that's the tool you want to use to sort of understand the workflow that's going on.
Oh yeah, Application Insight it's as magic for me as durable function is. You will have information more than you need to debug your problem, and you can tweak that kind of logging information up and down. But basically, I just leave it to the default. And when you leave it to that default, you will see durable functions, the framework. The exceptions that comes out of that framework, and you will see it that it will try to write to blob storage and have a failure. Right. It will retry. So all those kind of blubbing that you were like, oh, I didn't have to write that, but oh, look at that exception, and durable function handled it anyway, and your code still works fine. You know, oh, that's how much work is happening in the back, and a lot of people don't know, but there's a lot of storage errors that are happening just once in a while, and it happens on every provider.
Right.
And you need to be able to handle those errors.
Anything that can be recovered with a retry in a certain amount of time.
Exactly. So you need to be able to do those kind of things. And I love that you're able to visualize the execution of your functions through that tool. I would love to get a visual view of my functions at some point.
Yeah.
That is
I'd love to see
a
big fan out, right? Like a 30, 40, 50, 100 node fan out. Just see, all right, this orchestrator fired off, and then there was this fan out, and then there was this consolidation afterwards as everything finished up.
So if anyone in the community want to build it, the checkpoint and replay pattern is stored in storage. So basically you have all the information you need to build it.
Wow.
It's just that the Azure Functions team right now is busy on,
other things,
developing other features. Yeah. And this is that the main things that they want to work on instead of, performance improvement, cold start improvement, stuff like that. It's all about priorities.
Yeah, this responsible priority thing you're doing here, Max, this is going to end in tears. I want blinky lights. I'm here for the blinky lights. Give me more blinky lights.
More blinky lights.
More blinky lights, please.
Yes, lots of blinky lights. No, I totally appreciate it. All the data's there. It's just how do you visualize it?
This is all great stuff. Do you have a blog or a place that we can point people to for your resource?
So my blog is blog.myfullname.com. So blog.maximerouiller.com. I am a cloud developer advocate, so I will do most of my things. Most likely you will see me on different teams' blog or on Twitter. So I will provide all those links to you guys so you can leave it in the show notes.
Sure.
Awesome.
But the two ones that I really want to give is, again, my mixtape, aka.ms/serverless mixtape, and the aka.ms/dribble function sample, which will allow you to build a simple orchestrator centered around GitHub and retrieving opened issue count.
Great.
Excellent.
Maxime, thank you so much for spending this time with us. This is cool stuff.
Been a pleasure, man.
All right. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and, of course, in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.